structure, transverse vibration in a string. We did first harmonic, the minimum frequency with which a string is made to vibrate. Okay, that is the fundamental frequency or the first harmonic. Okay, the string was made to vibrate in one segment. Means string is vibrating as a whole, not in pieces. Okay, so we took this case, transverse vibrations in a string. Okay, so we took a string of length L. It was made to vibrate as a whole in one segment. The ends of the string were fixed, they were made nodes, and then in between the two nodes, exactly in the middle, there is a antinode. The node is a point where pressure is maximum, displacement is zero, particle is not free to vibrate. Okay, the string has been fixed at its ends. So ends are made node, and then this string is made to oscillate. Okay, in one segment only. Then the length of the string was L, and you also know that between two consecutive nodes, the separation is lambda by 2. So that means lambda by 2 is equal to L, or lambda is equal to 2L. We had velocity of transverse wave T by m under root, where T was a tension, m was mass per unit length, and then v was the speed of the transverse wave. This is also equal to n lambda. So equating these two, you get n lambda is equal to T by m under root. Here frequency is 1 over lambda T by m under root. And when string is made to oscillate in one segment only, then you have lambda is equal to 2L. So if you replace this by 2L, then you get the frequency with which this string is made to vibrate in one segment as a whole. This is the minimum frequency with which a string can be made to oscillate when both ends are fixed. Okay, the same length can be made to oscillate in two segments also. For example, though the length is same, ends are fixed, they are node, then same length is made to oscillate in two segments, which means here you have created an extra node. This is empty node, this is empty node. Okay, and this is lambda. It's one wave only. I told you the reflection of wave. This is the incident wave and this is the reflected wave. Two waves coming from opposite side, they superimpose. Result is standing wave. Then you had the equation for standing wave. Y is equal to 2a cos kx. Kx means 2 pi by lambda into x into sine of omega t. This was the equation of standing wave. Okay. Now here x is 0. At this point x is equal to L. Here x is equal to L by 2. Making use of this equation for standing wave at different values of x, what is the displacement? You know, here at this point x is 0 and y is also 0, but at this point x is equal to L but y is equal to 0. the ends of the string are fixed, means ends are not allowed to oscillate, that means ends are made nodes. And between two nodes there is one antinode. Two nodes never come together, they are separated by antinode. Similarly, two antinodes will never come closer, they will be separated by node. In standing wave, nodes and antinodes, they are found at regular interval. Okay? And now it is up to you to make the string vibrate as a whole in one part, or you can make the same length of the same string vibrate in two segments. Okay, in this case, what will happen? If you find out the frequency, in this case, frequency will be 1 over lambda T by m under root, lambda is equal to L. So therefore, here you have 1 over L T by m under root, and if you multiply and divide by 2, then you will get this frequency. Let it be N1. If this is N, this is the minimum frequency, lowest frequency with which string is made to oscillate. This happens only when string is made to oscillate in one part. Okay, इससे कम frequency से आप string को vibrate नहीं करा सकते. Minimum frequency. This is called fundamental frequency. Fundamental frequency, or it is also given a name first harmonic. First harmonic. Okay, इसको हम नोट भी बोलते हैं, fundamental note, lowest frequency. And when same string is made to oscillate in two parts, the frequency is now this. How this is related to fundamental frequency? Compare this and this. You will find this is, let us say N1, it is twice of N. This is N, fundamental frequency. That means when you make the string vibrate two segments, the frequency gets doubled. Okay? And this frequency, which is twice of the fundamental frequency, is called second harmonic or first overtone. Second harmonic, first overtone. Okay? Though you make the same string vibrate in three segments, same length, then ends are fixed, which are nodes, then here one segment, second segment, third segment. Same length, same string, same tension, same aspirant length, but in this case you will find the frequency will be different, but it will be related to the fundamental frequency, first harmonic. In this case, what will be L equal to? This is node, this is also node. Between two consecutive nodes, separation is lambda by 2. This is also lambda by 2. This is also lambda by 2. That means total length will be 3 lambda by 2. And lambda here will be, in terms of length, 2 by 3 L. Lambda is 2L by 3. Now frequency, let it be N2, which is given by this equation, 1 over lambda T by m under root. Here it is 3 by 2L T by m under root. And this will be 3 times the fundamental, because this is the fundamental frequency. Okay? So when string is made to oscillate in 3 segments, frequency becomes thrice the fundamental. And if you make the same string vibrate in 4 segments, you can generalize. The frequency will be 4 times the fundamental. Got my point? So if you generalize, you get the frequency P over 2L T by m under root. This frequency, which is 3 times the fundamental, is the third harmony and second overtone. Third harmony and second overtone means the number of overtone is one less than the number of harmonic. Third harmonic, second overtone. Second harmonic, first overtone. And this is the fundamental frequency. This is the first harmonic. This is the fundamental note. Minimum frequency with which thing can be made to oscillate. You might have seen on TV when there is a singing competition. A particular singer is given a particular sound. Though when the judgment is made, then you might have seen the comments. The judge will give a comment. Song which was given to you was very typical. But you were supposed to sing the same song in a higher note. Higher note. फ्रीक्वेंसी आपकी ज़्यादा होनी चाहिए थी, साउंड शरील होनी चाहिए थी. आप लोअर नोट पे ला गए, आपको हायर नोट पे गाना था. जैसे मान लीजिए आपको कहा जाए, आपको ही गाना दिया जाए, ऐ मेरे वतन के लोगों, ऐ मेरे वतन के लोगों, जरा आँख में भर लो पानी, जो शहीद हुए हैं उनकी जरा याद करो कुर्बानी. Mean I am not a singer, but I know physics, I know the notes. Okay, तो कहाँ आवाज़ को श्रील करना, फ्रीक्वेंसी हाई करनी थी, और कहाँ उसको डाउन करना था, ये सिंगर जानता है. ओके, अब आप नेशनल एंथम, इंडियन नेशनल एंथम सिंग करें तो उसमें इतने अप्स एंड डाउन्स नहीं है. जन गण मन अधिनायक जय हे भारत भाग्य विधाता. But when you end this national anthem, Jai He, Jai He, Jai He, singer knows where he or she is to sing in a higher note. Frequency high means आवाज पतली, ठीक है ना. और फ्रीक्वेंसी अप करनी है मीन्स जिस हार्मोनिक में आप सिंग कर रहे हैं, इट वॉज रिक्वायर्ड के यू सिंग इन हायर नोट. इससे हाई फ्रीक्वेंसी पे सिंग करना तो वहाँ. देन कमेंट्स वर रिगार्डिंग एनर्जी लेवल, कि वहाँ आपकी एनर्जी लेवल डाउन हो गई, है ना. हायर नोट में गाना था, एनर्जी लेवल कम हो गया. लेकिन जो अच्छा सिंगर होगा उसको ये मालूम है कि हाउ मच टफ सॉन्ग यू कैन बी गिवन. आज के तो बड़े टेढ़े मेढ़े सॉन्ग्स आ रहे हैं, उनकी जो लैंग्वेज है इतनी टफ होती है, और सिंगर को उसके अकॉर्डिंग अपनी नोट को अप एंड डाउन करना होता है, एनर्जी लेवल कंट्रोल करना होता है, तब वो प्रॉपर सिंग कर सकता है. ठीक है ना. पहले हारमोनियम क्या होता था, हारमोनियम में क्या होता था, देयर वर ऑक्टेव, सा रे गा मा पा दा नी सा, सारे गा मा पा दा नी सा, फिर उल्टा चलते नी दा प मा गा रे सा. अब सारे गा मा पा दा नी सा और सा नी दा प मा गा रे सा, सा से शुरू किया, सा पे एंड किया, ये ऑक्टेव है. लेकिन एक ऐसा सिंगर आ गया हारमोनियम पे, उसने गाना गाना था, बोले यार जो मैं ट्यून निकालना चाहता हूँ, जो मैं सुर निकालना चाहता हूँ, है ना, ये उसमें हारमोनियम नहीं निकाल पा रहा. फिर आ गया फिजिक्स वालों के पास, यार ये हारमोनियम ये आवाज़ नहीं निकाल रहा. हमने कोई बात नहीं है, आप इसको थोड़ा चेंज कर देते हैं. आपने देखा होगा हारमोनियम में एक ब्लैक नॉब्स होते हैं, वाइट नॉब्स होते हैं, ठीक है ना. तो वो जो बाद में वो तो नॉब्स लगाए गए, क्योंकि सिंगर ने कहा कि ये ट्यून यहाँ से नहीं निकल रही, इसके लिए आपको हारमोनियम को मेंड करना पड़ेगा. तो किया गया. अब उसमें 13 नोट आ गए, 13 डिफरेंट फ्रीक्वेंसी, उनकी कॉम्बिनेशन. ओके. तो कई बार एक ही स्टेज पे ऑर्केस्ट्रा चल रहा है, डिफरेंट म्यूजिकल इंस्ट्रूमेंट्स, दे आर बीइंग प्लेड बाय डिफरेंट म्यूजिशियंस एंड डिफरेंट फ्रीक्वेंसीज आर कमिंग आउट. फिर कि जब वो प्रोग्राम शुरू करते पहले सेटिंग करते हैं. सेटिंग मीन्स कहीं बीट्स तो नहीं पैदा हो रही, बीट्स ऑफ सडन राइज एंड फॉल इन द इंटेंसिटी ऑफ साउंड. बताया ना आपको बीट्स फॉर्मेशन इज आल्सो केस ऑफ सुपरपोजिशन. इसमें सडन राइज और फॉल इन द इंटेंसिटी ऑफ साउंड ड्यू टू सुपरपोजिशन of two waves going in the same direction but having slight difference in their frequencies, and there was a restriction on the frequency difference. Difference should not be more than 10 to give many a persistence of hearing. अगर एक सेकंड में 10 से ज़्यादा बार ये rise and fall in the intensity of sound होगा, अब ये many will fail to detect the variation in the intensity of sound. सिर्फ 10 तक वो रिकॉग्नाइज कर सकते हैं. ओके तो अगर मान लीजिए स्टेज के ऊपर 10 म्यूजिशियन है, उनके म्यूजिकल इंस्ट्रूमेंट डिफरेंट है, उनके साउंड निकलनी है, डिफरेंट फ्रीक्वेंसीज की निकलनी है, फिर जो लिसनर्स है उनको वेव को बनाओ क्या कि जो फ्रीक्वेंसी का डिफरेंस 10 से ज़्यादा कर दो, बीट्स बनेगी पर वो सुन नहीं पाएंगे, डिफ्रेंशिएट ही नहीं कर पाएंगे. राइज हुआ या फॉल हुआ इन द इंटेंसिटी, difference between the frequency of superimposing waves in case of formation of beats is more than 10, the listener will not be able to recognize the variation in the intensity of sound. Okay, तो उसे 10 से ज़्यादा डिफरेंस कर दो या डिफरेंस खत्म कर दो, क्योंकि 10 से कम होगा तो वेरिएशन आएंगी सडन, तो लिसनर्स को अच्छा नहीं लगेगा. एकदम इंटेंसिटी बढ़ गई, एकदम घट गई, ठीक है ना. बीट्स का कंसेप्ट है. लेकिन अभी हम स्टैंडिंग वेव की बात कर रहे हैं. स्ट्रिंग इज मेड टू वाइब्रेट इन वन सेगमेंट. ओके, सेम स्ट्रिंग, सेम लेंथ, सेम टेंशन, सेम मटेरियल, mass current length, but it's made to vibrate in 2 segments. Frequency becomes double than the fundamental. ये lowest है. इससे कम फ्रीक्वेंसी से आप स्ट्रिंग को वाइब्रेट नहीं कर पाएंगे. Okay, now it is up to you which frequency you want, which note you want. Then make the string vibrate in different segments. When it is made to vibrate in 3 segments, frequency becomes 3 times. Then we generalize, this is the harmonic and nth harmonic. If it is second harmonic, number of segment 2, okay, frequency double. Here what is P? Number of segment. As in this case, number of segment 3. So if you replace P by 3, the frequency becomes 3 times the fundamental. Got my point? So P here is number of segments in which string is made to oscillate, and N is nth harmonic. If same length of the string is made to oscillate in 5 segments, the value of P will be 5, harmonic will be 5th harmonic, but 5th harmonic will be 4th overtone. The least frequency is fundamental or first harmonic, and frequency higher than that are overtones or higher harmonics. Got my point? Clear? So these are all the examples of transverse vibrations in a string. It is a case of superposition of 2 waves which are identical. They were traveling in opposite direction. They were traveling simultaneously. They were traveling independently. But coming from opposite side, they reach at a point in the space at the same time. What was the result? Formation of node and antinode. Energy will get restricted. That's why it is given in a standing wave. This is the expression for the standing wave. जब 2 वेव सुपर इम्पोज किया डिफरेंट डायरेक्शन से आने पर ये नई वेव बनी, तो ये उसकी एम्पलीट्यूड थी ऑफ द न्यू वेव, फ्रीक्वेंसी सेम थी. ओके, जो इंटरफियरिंग वेव थी जिन्होंने सुपर इम्पोज किया, देवर y1 is equal to a sin omega t minus kx, then y2 is equal to a sin omega t plus kx. No, this is the case when there is only change of direction. Two waves coming from opposite direction, but they are having same frequency, same wavelength, same phase. The only difference between these two waves, the directions are opposite. And they reach at a point in the space at the same time. When they reach at a point in the same time, then that point is point of observation. And at that point, what is the result? What is the net result? Net result is standing wave. And in standing wave, we talk about node and antinode. Okay. So where standing wave is formed, either there will be node, means at that point where two waves coming from opposite direction they reach at the same time, that point will not be allowed to oscillate. Pressure will become maximum. Displacement will become zero. According to this, if this is a node, it means here displacement y is zero. Okay? And here x is equal to L, but here also y is zero. Here x is zero, y is also zero. यहाँ से वेव चली है. ओके, और रिफ्लेक्ट हुई है डेंसर मीडियम पे. रेयर टू डेंसर जब जाती है और डेंसर टू रेयर जाती है तो क्या चेंजेस आते हैं? आई टोल्ड यू यस्टरडे, wave goes from rarer to denser. After reflection, there is a phase difference of pi, which means अगर ये across था तो ये ड्रॉप बन जाएगा रिफ्लेक्शन के बाद. फेज डिफरेंस पाई का मीनिंग ये है. डायरेक्शन तो चेंज होगी. रिफ्लेक्शन का मतलब क्या है? देयर इज अ चेंज ऑफ डायरेक्शन. वेव विल बी सेंट बैक इन द सेम मीडियम. But phase difference of pi means if it is a superposition of longitudinal wave and there is a case of superposition in which standing wave is formed, or there is a case of reflection, then compression will be reflected as rarefaction. Okay. So, if you apply this expression, which is an expression for the standing wave, amplitude is given by this, which is x dependent. It is not time dependent. Means अगर ये displacement zero है और ये wave standing wave बनी है, कितने टाइम के लिए भी बनेगी? This will remain node. टाइम का इस पे कोई इफेक्ट नहीं पड़ेगा. यहाँ displacement zero ही रहेगी with the passage of time. जहाँ x zero है, y will remain zero. At the point node, displacement will be always zero. It will not change with the passage of time. क्योंकि here amplitude is independent of time. ये देखो, this is the amplitude. This at this point, amplitude is what? Maximum value of y. X is zero, displacement is zero. तो यहाँ x zero put करो, तो y zero आता है. लेकिन यहाँ x L put करो, क्योंकि L is the length of the string. जब वेव यहाँ से यहाँ आ गई, x डिस्टेंस कवर कर लिया, इक्वल टू L जो इसकी लेंथ है. ओके, तो x इज इक्वल टू L पुट करो, और L यहाँ कितना है? here लैम्डा बाय 2. L पुट करने का मतलब क्या है? x इज इक्वल टू L and L इज इक्वल टू लैम्डा बाय 2. when string is made to vibrate in one part, and here x is equal to L, here x is equal to L, but L is equal to y. L is equal to lambda. L is equal to lambda. If you take this case, x is equal to L, but L is equal to lambda by 2. In this case, here x is equal to 3 by 2. यहाँ से यहाँ वेव आई. X is equal to L, but L is 3 by 2 lambda. But y here is 0. Why? Because it is node. 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 Because it is n Node is that part where displacement is zero. Pressure is maximum. Particle is not allowed to oscillate. फिक्स कर दिया. इलेक्ट्रिक गिटार में वायर के जॉइंट्स है, वहाँ आपने स्क्रू लगा के उसको टाइट कर दिया, तो स्ट्रिंग में टेंशन आ गई. बिना टेंशन के ट्रांसवर्स वेव की प्रोपेगेशन इज नॉट पॉसिबल. गॉट माय पॉइंट? तो हमने जनरलाइज कर लिया. nth हार्मोनिक will depend upon number of segment. If there are 3 segments, then this will be third harmonic. P will be 3, number of segment will be 3. Okay, and if you express number of segment in terms of overtone, if it is third harmonic, it is second overtone, one less. अगर यहाँ P है, तो in case of overtone, so this will be NP minus 1. NP minus 1 means frequency of overtone. 3 segment, second overtone. Okay, P is equal to 3. P is the number of segment. N is harmonic. The segments are 3. This will be third harmonic. But in case of, in terms of overtone, number of segment 3, frequency third harmonic, but second overtone, one less. So you can express the same result in the form of this harmonic or in the form of overtone. Which overtone you are talking about? Which harmonic you are talking about? If I say, can you write an expression for 10th harmonic? The thing will be made to vibrate in 10 segment. Number of segment will have to be 10. If I want 7th overtone. 7th overtone means 8th harmonic. Okay? 8th harmonic means number of segment will be 8. String will be made to oscillate in 8 segments. Frequency will be 8th harmonic and it will be 7th overtone. Got my point?
Yes, sir.
Now, transverse vibration in a string, they obey certain laws. Now, what are those laws? Laws of transverse vibration in a string. When string is made to oscillate in one segment, then the length of the string is lambda by 2, because this is node, this is node, this is antinode. The frequency will be 1 over lambda t by m under root. Here lambda will be 2L, so frequency will be 1 over 2L t by m under root. This is first harmonic. First harmonic, or it is fundamental frequency. Or you can say this is the lowest frequency with which string can be made to vibrate. Okay, so this fundamental frequency 1 over 2L t by m under root. The first law is law of length. You look at this relation, fundamental frequency depends upon L, T, M under root. This relation you can derive by the method of dimensions also. If this question is out of the unit and dimension, then you will be given that if string is made to vibrate with the fundamental frequency n, which depends upon the length of the string, tension, and mass per unit length. L is the length of vibrating part of the string. Length of the vibrating part. Okay? Then T is the tension. Tension has the unit of force. It has the dimension of force. Tension is a force. I told you, transverse vibration in a string is not possible without tension. Then what is M? It is linear mass density. Linear mass density, mass per unit length. Okay, its dimension formula will be M L minus 1 T0. Tension as the dimension of force, ML T minus 2. And L is basic quantity. And frequency as M0, L0, T minus 1. Okay? So, this expression for the fundamental frequency of transverse vibration in a string can be derived by the method of dimension also. If you are given this data, that fundamental frequency depends upon the length of the vibrating part of the string, tension in the string, and mass per unit length. Then by the method of dimension you can find out the value of A, B, C, which are the dimensions of these three quantities. Then you can get this relation. But I am discussing the laws of transverse vibration in a string. Okay, so system will obey certain laws. Here string is made to oscillate in one segment. We are talking about the fundamental frequency, minimum frequency, the first harmonic. Okay, and the first law is the law of length. It states that fundamental frequency of transverse vibration in a string is inversely proportional to the length of the vibrating part of the string. N and L, they are written like this. N is inversely proportional to L. Okay, or you can say N1 over N2 will be L2 by L1 under root. Inversely proportional to length. Under root. N1 over N2, N2 by L1. It is out of under root. This is law of length. Okay, so you can verify this law by an apparatus which is called sonometer. Sonometer is a device which will help you in verifying the various laws of transverse vibration in a string. It is a box, wooden box. Okay, and here there are two holes, wooden box. Then here there is a peg. Then there is a string. Then there is a pulley which is fixed to this. This is pulley. Here there are two wedges, sharp wedges, which will stick only this part of the string to vibrate. Wedges होते हैं sharp, और this part of the string is made to oscillate. What is the source of tension? Source of tension are the slotted weights. यहाँ weights होते हैं. This is a hanger, and these are slotted weights. हाफ केजी का एक वेट होता है। हैंगर के ऊपर ये स्लॉटेड वेट्स आप इसमें डाल सकते हैं। कैसे डालते हैं? ये आयरन का हैंगर है, इसका बेस है, यहाँ वेट्स हैं। इसमें कैसे इंसर्ट करते हैं वेट्स? वेट्स में ग्रूव होता है साइड में, और हैंगर में भी थिन पार्ट, और वो ग्रूव के थ्रू ये इसको ऐसे डाल के आप इसको नीचे ले देते हैं। तो दिस इज ए सोर्स ऑफ टेंशन। टेंशन इज इक्वल टू mg। हाउ मच weight you have attached over here? Each weight is of half kg mass. Okay, and the weight of the hanger is also half kg weight. We have 1, 2, 3, 4. That means 2 kg masses, and the corresponding tension will be 2 into the value of g. Tension is weight which we have put in the hanger. More weights put in the hanger, more tension. Okay, then you have a law of tension also. Law of tension, the fundamental frequency, how it is related to the tension. Second law is law of tension. It means fundamental frequency directly proportional to square root of tension, which means n2 by n1 will be t2 by t1 under root. If you are verifying law of tension, you have to keep other factors constant. You can change only tension, you cannot change length and mass per unit length. Okay. So in case of verification of law of tension, you will keep L and M same. You will vary only tension. On changing tension, you will find the corresponding frequency with which thing is made to vibrate will change. Note the relation. Fundamental frequency directly proportional to square root of tension. This is called law of tension. Got my point?
Yes, sir.
तो विद द हेल्प ऑफ दिस इंस्ट्रूमेंट विच इज कॉल्ड सोनोमीटर, इसका कंस्ट्रक्शन आपको बताया, देयर इज अ वुडन बॉक्स विद 2 होल्स फॉर द पैसेज ऑफ एयर. ओके, देन देयर इज ए पैग. पैग मीन्स यहाँ इस स्ट्रिंग को यहाँ टाइट किया गया, पर पूरी स्ट्रिंग को ऑसिलेट नहीं कराया जाएगा. जो पार्ट बिटवीन द 2 वेजेस होगा, ओनली दैट इज मेड टू ऑसिलेट. ओके, तो इसको कौन ऑसिलेट कराएगा? There is a driver. The driver is tuning fork. Tuning fork. This is a stem of the tuning fork. These are the 2 prongs. Okay. And it has its own frequency. Let us say frequency with which this prong of the tuning fork will be made to oscillate is, let us suppose, 500 hertz. This will be the driver, and which will be the driven body? This part of the string. This driver will make this part of the string vibrate with this frequency. This must be the natural frequency of this part of the string. We have studied in simple harmonic motion, free oscillations, natural oscillation, forced oscillation, maintained oscillation, then resonant oscillations. Resonant oscillation means the frequency of the driver and driven, if they match, the driver can pass on maximum energy to the driven body. In that case, amplitude of vibration increases. जो ड्रिवन बॉडी है, जिसको वाइब्रेट कराना है और जिसने कराना है, जैसे आप किसी को झूला देना चाहते हैं, वो बच्चा है अपने आप झूला नहीं ले सकता, तो वो बच्चा ड्रिवन है, और जो उसको पुश करेगा मीन्स एनर्जी सप्लाई करेगा, विच विल मेक दैट चाइल्ड स्विंग, सिंपल हार्मोनिकली, उसको ड्राइवर बोलेंगे। ड्राइवर का काम एनर्जी सप्लाई करना, ड्रिवन जिसने वाइब्रेट करना। और कई बार अगर मिस मैचिंग हो जाती है, फोर्स ऑसिलेशन आर प्रोड्यूस, तो ड्राइवर जब ड्रिवन बॉडी को ऑसिलेट कराना चाहता है, मैचिंग नहीं होती है, तो बच्चा रोने लग जाता है, तुम मुझे मत झूले दो, तुम मुझे गिरा दोगे। दैट मीन्स इट मिस मैचिंग हुई है। और अगर फिर भी ड्राइवर नहीं मानता, तो बच्चा वो रो रहा है, झूले उसको दिए जा रहे धक्के से, तो ये तो फोर्स ऑसिलेशन है, जबरदस्ती की जा रही है, ठीक है ना। अगर कई ड्राइवर हों और ड्रिवन बॉडी बच्चा एक है, कई ड्राइवर उसको झूला देना चाहते हैं, तो वो बच्चा सेलेक्ट करेगा, भैया तुम दो झूले, तुम बड़ा ढंग से झूले देते हो, तुम गिराते नहीं हो, ठीक है ना। तो इसका मतलब ड्रिवन बॉडी ने एक ड्राइवर को एक्सेप्ट कर लिया है, और वो ड्राइवर अब ड्रिवन बॉडी को जब झूला देगा, वो कहेगा और जोर से, क्योंकि मैचिंग हो चुकी है ड्रिवन और ड्राइवर की। तो यह ड्रिवन बॉडी इज दिस पार्ट ऑफ द स्ट्रिंग। इसको आप एडजस्ट करेंगे रेजोनेंस के लिए, यू हैव टू एडजस्ट द पोजीशंस ऑफ दीज टू वेजेस, W1 W2 are the wedges, W1 and W2. Okay, here there is a fixed pulley and string is passing over the pulley, and this is free end of the string which is attached to the hanger, and you can insert slotted weights in the hanger to reduce a particular value of the tension. Got my point? So driver is the tuning fork, driven is a part of the string, and what you want resonance. कि ड्राइवर जो है ड्रिवन को उसकी नेचुरल फ्रीक्वेंसी से ऑसिलेट करा दे, जिस फ्रीक्वेंसी से वो बच्चा झूला लेना चाहता है खुद, और ड्राइवर भी उसी फ्रीक्वेंसी से उसको ऑसिलेट करा दे, तो मैचिंग है। ओके, तो तब रेजोनेंस होगा। रेजोनेंस में फिर ड्राइवर जो है ड्रिवन को मैक्सिमम एनर्जी ट्रांसफर करेगा टू मेक हिम और हर वाइब्रेट विद हिम और हर with his or her natural frequency. जो स्विंगिंग चाइल्ड होगा विल एंजॉय, ठीक है ना। तो यहाँ दिस ड्राइवर इज ट्यूनिंग फोर्क, इट हैज इट्स ओन नेचुरल फ्रीक्वेंसी दैट इट बी 512 हर्ट्ज। देयर आर different tuning fork with different frequencies, 250 hertz, 512 hertz, 280 hertz, 480 hertz. Okay, but if you say you have this driver which is a tuning fork with a 512 frequency, it is its natural frequency. Whenever the prongs of this tuning fork will be made to oscillate, it will always oscillate with this frequency only. And this driver wants that this part of the string should also vibrate with the same frequency. Its frequency, natural frequency, this, driver frequency, this. If they match, then there is a resonance. If this is not equal to this, then forced oscillation. String is not vibrating of its own. It is made to oscillate. And for that you require a source of energy, external agency, that is a tuning fork, which is called a driver. This will make this part of the string vibrate. So this is a driver, this is a driver. We want resonance. For that you will have to adjust the position of these wedges. You have to find out the length which will vibrate with the frequency of driver. तो कौन सी length है तो ढूंढनी है। Okay, and let us suppose on adjusting the position of these two wedges, this driver of this frequency makes this part of the string vibrate with its own natural frequency, means there is a resonance. So how will you test the resonance has taken place? There is a paper rider, a small piece of paper, इसका V shape ऐसे भी टाइप बना के उसको आप मिडल में जहाँ एंटी नोड है, क्योंकि ये नोड है, बीच में एंटी नोड है, बीच में एम्पलीट्यूड मैक्सिमम है, दिस इज the case node, node, antinode. तो यहाँ बीच में antinode होगा. Antinode is a point where displacement is maximum, pressure is minimum, and the string is made to oscillate. Free to oscillate. Okay? तो वहाँ ये पेपर राइडर रखेंगे. इस ऐसे टाइप का पेपर राइडर होगा, V type, and that will be put on this string, and if this flies off, it will fly off if amplitude is maximum, and if resonance has taken place, the driver has made the driven body to vibrate with its own natural frequency. If resonance has taken place, okay, then if you put rider, paper rider of this type on the string in the almost middle part, it will fly away. If the test resonance has taken place. In that case only, you will note down this length. This is the length of the vibrating part. Okay, ये नहीं कि दो wedges कहीं भी रख दो and then you make this tuning fork produce vibration in the string, and if resonance has not taken place, then this paper rider will not fly off. Tuning fork, so it is made to, the rubber pad is there. This is the tuning fork, two prongs, and from where I am holding, that is the stem. Its frequency is written here 512 Hertz. Okay, and these two prongs, whenever prong is made to vibrate, it will vibrate with its frequency, which is 512. 512 oscillation in 1 second. Your eye will not be able to see, but your skin will be able to detect. This prong of the tuning fork is made to oscillate. This will be stuck on the rubber pad. It will be held like this, inclined position. Then it is stuck not like this, like this. Any one of the two prongs will be made to strike on the rubber pad. Okay? इसको आप strike करेंगे, you will find, if you touch, it is vibrating with 512 frequency, the last frequency. And when you touch, the energy with which this is oscillating with 512 Hertz frequency, that energy will be passed on to your skin. And in your skin, force oscillation will be produced. Okay, and then what will happen? When energy is transferred from prong to the skin, there will be absorption. ये skin इतनी fast vibrate नहीं कर पाएगी. Okay, but you can feel the vibrations are taking place. अगर आप इसको मैं सही करता हूँ, हाथ लगाएं, तो कई बार डर लगता है, ऐसा लगता है करंट है. करंट नहीं है, 512 फ्रीक्वेंसी से prong वाइब्रेट कर रहा है, और जब आप टच करते हैं तो वो एनर्जी आपकी स्किन में ट्रांसफर होने की कोशिश होती है. ओके, जब वो एनर्जी आपकी स्किन में ट्रांसफर होती है, और अगर आपने पहले कभी एक्सपीरियंस नहीं किया, तो पहले फर्स्ट टाइम तो आप डर जाएंगे कि यह करंट है इसमें, जबकि करंट नहीं है. देयर इज नो सोर्स ऑफ करंट हियर. ओके, ओनली वाइब्रेशंस, ओनली simple harmonic motion of the prong. So this is the driver in this sonometer case, which is an instrument to verify the laws of transversal vibration in a string. There are 5 laws. First law of length, second law is the law of tension. When you are verifying one law, you have to keep other factor constant. When you are verifying law of tension, you have to keep the length and the mass current length, means material of the wire should remain the same. Only tension is to be changed. Let us suppose you double the tension. Here you make tension 4 times. If T2 is 4 times T1, then frequency will become twice the previous frequency. T2 by T1, T2 is 4 times T1. Okay, the ratio will be 4. When you take square root, it will be 2, and T will be 2 times N1. Tension 4 times कर दिया, frequency double हो गया. This is law of tension. Okay. Fundamental frequency. I'm talking about directly proportional to square root of tension. You perform keeping L and M same. Perform this experiment with the tuning fork of different frequencies. अगर फ्रीक्वेंसी चेंज करते हैं, फ्रीक्वेंसी चेंज करेंगे तो किस कारण चेंज होगी? या तो आपने टेंशन चेंज की, इधर यह चेंज द मटेरियल ऑफ द वायर, मोटी वायर ले ली, मटेरियल कोई और ले लिया, या लेंथ कम ज़्यादा कर दी, टेंशन कम ज़्यादा कर दी, फ्रीक्वेंसी पे फर्क पड़ेगा. इसके एल, टी और एम, ये three factors on which this fundamental frequency depends. But I am to verify the law of tension. If I am to verify the law of tension, you will change only the tension. Tension यहाँ है, source of tension is here. Hanger is there, slotted weights are there. Okay, then whatever weight you attach over here, including the weight of the hanger, that will give the tension, M into G. यहाँ मतलब आपने 4 किलो रख दिया into G, that will be tension in Newton. क्योंकि weight है, weight is a force of gravity. Weight is one of the forces. Okay, तो टेंशन चेंज करनी है. एक बार यहाँ आपने 2 किलो लगा दिया, एक बार 4 किलो लगा दिया, या 2 का 4 टाइम कर दिया, 8 किलो लगा दिया, फिर देखते हैं कि फ्रीक्वेंसी डबल होती है कि नहीं. अदर फैक्टर्स यू हैव टू कीप कांस्टेंट. ओके, so if you want to verify the law of length, you will change only the length. For two different length, two different frequencies, keeping tension and mass per length same. Got my point? So what is the third law? Third law of transverse vibration in a string. You can derive from here relation between n and small m. That is the law of, that is called law of mass per unit length. Third law, law of mass per unit length. That is fundamental frequency inversely proportional to square root of mass per unit length. It is linear mass. M is linear mass density, mass per unit length. It will mean N2 by N1 equal to M1 by M2 under root. Mass per length means आप एक बार वायर ऐसी लेते हैं जो थोड़ा हैवियर है, एक बार लाइटर लेते हैं. ओके, तो मास पर यूनिट लेंथ, ये आप डायमीटर बढ़ा देते हैं, लेंथ वही रखते हैं, मास बढ़ा देते हैं, डायमीटर बढ़ा देते हैं. ठीक है, वॉल्यूम बढ़ जाएगी, डेंसिटी वही है, मास बढ़ जाएगा. तो दिस इज द लॉ ऑफ मास पर यूनिट लेंथ. नाउ देयर आर टू सब लॉज. There are two sub-laws. That is law of diameter of the string, and fifth one is law of density. Law of diameter, law of density, these are two sub-laws of transverse vibration in a string. If you have taken a wire is, the string is cylindrical, diameter is d, radius is r, length is l, and its density is, let us suppose, small d. This is the density of the material. This density is mass per unit volume. It is not the linear mass density. Okay? It is density. Density means mass per unit volume. So d is the density of the material of which this thing is made of. Capital D is the diameter. This is the diameter. This is small r is the radius. And the volume of this wire is cylindrical. Volume is area of cross section into the length. Pi r square, r is d by 2. Okay, this radius is half of the diameter. So volume of string. String is cylindrical. Volume of a cylinder is pi r square into h. H here is length. R is d by 2. It is the volume. And what the mass? Mass of string of length L. Mass is volume into density. This is mass upon volume. So mass of the string of length L is volume of the string into density. So we want small m, that is mass per unit length. The mass per unit length means the mass of unit length, that is pi d square by 4 into small d. Take L is equal to 1 meter, unit length. This is the mass of length L. I want mass per unit length. Okay, the total mass divided by total length. That will give you mass per unit length. That is small m. Now, if you replace this small m by this value, this is small m, it is in the denominator. So what will happen? 2 ऊपर चला गया, pi d square d. Just simplify, it will give you n is equal to 1 over 2l t by m. m की वैल्यू डालेंगे 1 over 2l, square root of 4 is 2. In the numerator you have only t, then pi d बाहर चला गया, small d अंदर. Square root of 4, 2 आ गया, square root of d square, d आ गया, l is already out. Okay. Now you have both the parameters, diameter of the string and the density of the material of the string. Now how fundamental frequency is related to each of these, that will provide you the new law. The law of diameter, which means fundamental frequency, is inversely proportional to diameter. 2 will get cancelled by this one. Okay, so you have this relation n is equal to 1 over d l t by pi d. Fundamental frequency. How is related to the diameter? It is inversely proportional. Or you can write n2 by n1 will give you d1 by d2. This is the law of diameter. So similarly, law of density, fundamental frequency inversely proportional to square root of density of the material of the wire. N2 over N1 will be d1 by d2 under root. So 3 main laws and 2 sub laws. Law of length, law of tension, law of mass per unit length, and then 2 sub laws, law of diameter and law of density. So this is all about transverse vibration, laws of transverse vibration in a string, which are verified by an instrument which is called sonometer.